so with this video, we're doing problem number 3. And you can see I've got a 12-volt power supply here, and I got 3 resistors, 1, 2, and 3. And we're trying to find VIR for all of our parts. Let's start with our total, because if we have our total, we can then make assumptions about other parts within the circuit. So I've laid out VT, IT, RT, V1, I1, R1, yada, 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 yada. So to find the total current or the total resistance, I need to now simplify this because these two are in parallel and then these two sets are in series. So I'm going to start by turning these into a single resistor. So for this, 1 over RT is equal to 1 over R1 plus 1 over R2 plus, well, I guess there's only 2 in parallel, so we're only going to do 2. So 1 over RT equals 1 over 4 ohms plus 1 over 8 ohms. That becomes 3/8 ohms, 1 over RT. And now 3 RT equals 8 ohms, 8 over 3. RT equals, what, 8 over 3, 8/3. And I have no pride here, no shame. My calculator, 8 over 3 is going to be like 2 something. 2.666. Repeating ohms. That's for this. So now I can redraw this, and now I treat it as a series. So 12 volts. We just combine those two into this one, and we still got our series. So here it's resistor 3, and it's 2 ohms. This is resistor, I'm going to call it 1, 2, because it's a mixture of the two. And it is 2.666 repeating ohms. Series is super easy. I just add these together. So 2 ohms plus 2.6 repeating ohms. I'm going to end up with my total current 4.6 repeating ohms. Great. Now to find the current. Here we go. I'm using my phone calculator here. To find current, it's V equals IR. So 12 equals I times 4.6. 12 divided by 4.6. 2.609 amps. I'm not paying attention to significant digits. That's good. All right. So now we've got our total values. Now, when things are in series and things are in parallel, things act differently. So let's just focus on our series. So here we got it in series. In series, the voltage is shared based on the ohms. In parallel, the voltage is the same. So let's just find out what our voltages are for V3 and then V1, 2. So it's kind of like we're making a separate circuit with our parallel. So let's see, R3. So V3 equals I. Okay, and then the current is the same between these two things. So let's see, current should be the same. So IT equals I1 plus I2 plus I3. That's what I'm talking about. So here, if V3, we're trying to find out, current 3 is 2.609 amps times a resistance of 2 ohms. So it should be, there we go, 4 2 times 2.609. So this is resistance. No, this is voltage. 5.218. So V3, 5.218 volts. Now, using deduction, that means that my R12 is going to be 12 minus 5.218. But just for good measure, let's figure this one out. So let's see, V, let's go 1,2, voltage of 1,2 equals the current 2.609 amps times the resistance, which is 2.6666, repeating. 2.609 times 2.6666. We get 6.957 V12. All right. And the voltage for two things in parallel is the same. So just to check, 6.95712 plus the voltage from before, 5.218. We get 12.17. Some error, but hey, that's pretty good. Let me get rid of that. Okay, so voltage of 1 equals 6.957. Voltage 2, 6.957 volts. Look at that. We're well on our way. So we got resistances. We've got, now it's V equals IR. So plug and chug. For V1, we get 6.957. 6.957 divided by 4. Current is 1.739 amps. V2, we have 6.957 divided by 8.8696. That's good. And just for good measure, I know that these two should add up to be the same as the current. They should add up to be my current. So when I add them together, I get 2.608. It is dead on the money because in series, ultimately everything's in series here. Our current value should be the same between R3 and the other things in series. So when you add up your current values of R1 and R2, it's the same, 2.609. 2.609 amps. Because in series, your total current is equal to the current of every single object. So these are your answers. Ta-da! How do I stop this?